started. Go over how to make contours from digital elevation map information that we freely downloaded from NOAA. And we're going to learn how to make all these different kind of contours. We're going to get all the data for free. And we're also going to learn how to make a box over this to represent a chart. So let's get started. So where you can get your information from. So there's two places I like to get my data from. I either get it from this web tool right here, which is National Center for Environmental Information, or I get it from this one right here, the Data Access Viewer. Let's first talk about this one. As you can see, this one looks a little messy. It's not, it just looks it. So what's on this one? Well, first off, this one's all bathymetric information. So let's go ahead and turn off this. And now we can see things better. Wherever you see some purple, that means that there is a survey with digital data. It's a bathymetric survey with digital data. So we'll go ahead and zoom in all the way down here to Houston, actually. As you can see, we have data there. Now, if you want to be able to download the data, I suggest you do surveys with bathymetric attributed grid files. These are called bag files. And if you want to be able to see what it looks like, go ahead and do bag footprint or bag color shade relief. Actually, do both of them. At this point, let's zoom into an area. Let's go to Norfolk, Virginia. All right. Here we are. You can see we got some beautiful bathymetry down there. And let's say I want the information right here. Let's say I find this really interesting. Actually, I don't want that information. Let's say I want this information. Whoa, what is that? That looks cool. Oh, what's this right here that they got clearly labeled for some reason? Oh, looks like there's something cool right there. Yeah, I want this data. I want to know more about this one, let's say. I can go ahead and click it. At this point, I could hypothetically open its survey, which was done 2011. So that's pretty recent. We can see who did it. NOAA ship Thomas Jefferson. Where was it done? And the survey information. We can go link to the ID. All right, so here we are. We open it up, and this is where it was done. There's a nice little Google map of it, and here's the actual data, and it's all to the mean low water. And it looks like we can download the combined bag right here at 4-meter resolution, or if we want the 2 of 2, we can get a 50 centimeter resolution, so even more finer resolution. I'll go ahead and download that right now. So we have a bag file to deal with. All right, so zoom back out, we can see that the downside of this chart, the downside to this tool is that it doesn't cover everything. So while these are very detailed surveys, and a lot of them are actually really, really interesting, and if you want to, you can go down to like Puerto Rico, and you can look at some really cool surveys down here. I happen to know that a lot of these surveys actually have like wrecks in them, so that's kind of a fun little Easter egg to find. And there's some really cool surveys up here in Alaska. Just some beautiful surveys. While this one's really useful, we're not going to use this as much in this tutorial just because the data is kind of hard to deal with, and I don't kind of like what it creates. So let's talk about digital elevation map footprints. So as you can see, a lot more information here. We'll go and turn off our bag stuff, and let's go ahead and turn on the color shade relief. Oh, look at that. Beautiful digital elevation. If you believe this, we've charted everything. So let's go ahead and zoom into a location here. Let's say right here, I want some digital elevation. I can click it, and you can see there's a bunch of information here. Or go here, and we can extract the data. I can see it just opened up the same thing we already have opened up in this tab, which is our digital elevation. So let's go ahead and start playing with this data. I'm going to close this one. If you want some data from here, go for it. But I will say before we exit out of this one, there's a lot more information in here than just the survey bag file. If you wanted to, you could zoom in, click an area, look at the survey. Wow, 1974. Some NOAA launch 1255. We can open that up. We can see what it covers, and there's actually some really cool information here. There's PDFs on the collection of the data. Looks like this one has XYZ sounding format. You can read so much information on this. Oh, there's even a picture of the vessel, what it looked like. Oh, that's so cool looking. All right, let's go ahead and close that. And start using this tool to get some digital elevation models. So the area I'm going to choose is based off of a chart I've already created. You can see that right here. If you want to make a chart like this, go ahead and use the custom chart creator prototype from NOAA. I already made a video that kind of described how to make it. So go ahead and click there if you want it. It's probably on the screen or it's probably down below. All right. So back to this, we're going to choose the area that I already chose, which is Amelia, Florida. I was going to type it in, then I remembered something. When you type something in here, it starts to draw the box for you, and I don't want that. I already know where Amelia, Florida is, so we'll start zooming into my location. All right. This is my location I want. Now, this is kind of cool. You can just draw a box. Now, if you are trying to create something off of a chart, I highly suggest you draw the box as close to that chart as you possibly can. All right, so here we are. We've now drawn a box and we have selected an area. We can then check out and go to our cart. So right now it's something on our cart, so we'll go ahead and start checking out. So first off, here's your information, next. And for this video, I just want to go over this. I would set my projections to UTM. I would set my range to 17. It automatically jumps to it, which is kind of cool. So I'll show that again. Geologic lat and long. UTM jumps immediately to zone 17. Really cool. Horizontal, leave at nat 83. And for this one, I want mean, lower, low water. What does that mean? It means that over like a 19-year tidal datums that this represents the lowest of the low of the water. So if we go look at a chart right here, that 19 right there is a 19 at the lowest low point. It can go higher, but it will never be lower than that. All right, so here we are. I've already kind of put that together. At this point, you're just going to email it to yourself. I'll go and eat to myself, and we'll cover what that looks like here in a second. I'm going to go ahead and fill it out myself, send it to myself, and zoom in. This is the data that we just downloaded. Go into my email, and at this point, we can start downloading it from this link here. And you'll notice that it'll come in with a job number, which you'll need to rename. Now that we've already downloaded our data, and as you can see, I've renamed my data as well. It comes in as this job, and I renamed it. We're going to drop it into QGIS to make some contours. So go ahead and drag and drop. We'll go ahead and exit out of this now. And here's your DM. As you can see, it is just a big black and white data set, but we're going to make some contours out of it. So we're going to go up to raster. We're going to go to extract, contour. At this point, you're going to name it. So I'll name mine contour AI for Amelia Island. And I'm going to set mine to 1. I've just done this enough times that I know that this data set comes in better at 1. But you set it whatever you want and play with it as much as you want. Hit OK. It's going to take a few seconds, and we're going to see it load here in a few seconds. Oh, here it comes. There it is. Cool. So it came in. The colors that it comes in as is going to be random. As you saw earlier, it was green, and now it's brown. So here's our data. If you're following along the tutorial for my Instructables video, you know that we're going to need to get rid of all of this land data later. But don't worry about it for now. For now, we're going to do something else. Here we have our contours. Now, if you've already made a chart, this should be, the next step should be easy. So let's go ahead and open our chart. Okay, so I have my chart opened right now. And what I need to get from my chart are my latitude and my longitude from my 2 corners. And I'm going to put those into a Google Doc. We're going to put these in a Google Doc, which I've already done. As you can see, I like to make it into 4 corners. You can also do this on a piece of paper, but for this format, I like to do it in Google Doc. Now we need to convert this information into UTM zone 17 for NAD 83. So how are we going to do that? Well, luckily, we have this handy converter, which I've linked down below. Go ahead and put this on half, and we'll put this on the other half. All right, so here's what we're going to do. We need to set this to NAD 83, select map datum to NAD 83. Now we're going to type in our, well, first we need to set this to 17 north, or whatever you have. And now we're going to type in our latitude and our longitude. So first, latitude, we're going to do 30, 34.50, 0, and then we're going to do 81, 28.93, convert. Oh, sorry, did it again. You need to make sure you have zeros here. We're going to hit convert, and now we have some eastings and some northings. And you'll also notice it gives you a nice handy location. And if we could look, that looks like it's right above Franklin Town, below Amelia City. And that looks to be in the same location. So at this point, I'm just going to copy and paste my northings and eastings in here. That's important for later. So we're going to do that 3 more times. Now we've done that 3 more times, we have all our northings and eastings for each corner. At that point, I no longer need this nice handy converter, but it's cool to see. Go ahead and close that out. These now 4 corners represent the 4 corners of our chart. We're going to now create a shapefile. So go ahead and move over your Google Doc, and we're going to go ahead and close the DEM so we can zoom in and out easier. And we're going to go up to Layers, Create Layer, Create Shapefile. We're going to make our shapefile a polygon. Make sure that is set to the correct coordinate reference system. And then we're going to give it a name. I'm going to name mine simply Shape File. Hit OK. Pick a location. Just name it Shapefile again. And now we've created our shapefile. At this point, we need to start editing our shapefile. You can either right-click on the shapefile in the layer panel, or you can click this nice little pencil. So, click this nice little pencil, or you could have right-clicked and toggled editing right here as well. And now that we're editing, we're going to make a shape. So we're going to add a feature. We're just going to click 4 times. 1, 2, 3, 4. And then we're going to right-click, enter an ID. I always just put in 1, hit enter, and there is your shapefile. Now we're going to need to edit each of these corners. So go ahead and select the node tool, and then we're going to select a corner, and you'll see down here is a spreadsheet, a little spreadsheet of some northings and eastings. We can see which each one of these are. So that is that corner, that's that corner, that is that corner, and that is that. Now you need to enter in your northings and eastings into the correct corner. Now that we have all these coordinates entered in, you can see our box right here. Go ahead and minimize that. And now we can stop editing. We'll go ahead and save our changes, yes. And at this point, you'll notice the box is not see-through. Well, let's go ahead and change the transparency on it, okay? Go into Properties. That was right-click, Properties. We'll go to Simple Fill. We'll pick the color, and we'll just bring it down to 100% transparent. Apply, okay. And there we go. Now we have our box. That box in the same place as our chart. Well, let's look. So, I have my chart pulled up. Let's look at these corners here, okay? Yeah, like a small little island right there. That goes down. Let's go ahead and zoom in here. Oh, There's that island right there. Island goes down right here. What about here in this corner? Looks like we have like some kind of island. Yeah, there it is. All right, it seems like I have my chart in the correct place. Now I need to export this as an SVG. Now I'm doing SVG because I'm working in Inkscape for the next part. And if you are looking for the whole tutorial, go ahead and click below and it'll get you the rest of the tutorial. But for right now, we're going to export it. So the first thing we're going to do is new print composer. Go ahead and click that. We're going to give it a unique name. So I'm going to call it AI for Amelia Island. Okay. Go ahead and make that the full screen. And now we need to first make our paper the size we want. For me, I'm going to go ahead and make this custom. And I'm going to go ahead and change this to inches. And we're going to make this a 12 by 12 piece of paper. Okay, now I need to actually put my data in there. So you can do new map extent, and then you can just draw it right here. Now you'll notice it looks like it's really zoomed out. So why is that? Well, it's that we are already zoomed out on this. So let's go and adjust that. We'll zoom in as much as we can so we can expose. We'll zoom in as much as we can so we can have our box there, but still be able to see it. So let's go back to a new print composer. So if I click that button again, it will break a whole new one. So back in the print composer, let's go and delete the new map we just made. Let's try again. You'll notice it's a little bit more zoomed in this time. Well, that's still probably more information than I want. So I'll go ahead and do some edits. All right. So the data I want. Okay, now that I've messed around a bunch of times and accomplished nothing, let's go ahead and do this. We're going to add in some of these lines. As you can see, I'm clicking up here, which creates a line. And I'm putting that in there. The only reason I'm doing this is so I can adjust it so that it takes up the most of the box I can, which will set me up well in the future. Now you'll notice it looks a little pixelated. Don't worry, that's not how it's going to export. It's going to export pretty smooth, so don't worry about that. All right, this is probably as good as I'm going to get it. So now we'll go up to Composer, Export as SVG. Gives us a little warning here. Don't worry about it. I haven't actually run into problems yet. Go ahead and hit Close. Now we're going to export it. I went ahead and set up a folder already for it, and we'll call it Amelia Contours. And save. At this point, you have now exported your entire contours. For the next part of the tutorial, go ahead and click on this video. Otherwise, if you're just looking at how to create contours, we're all done. Now at this point, we have finished with our contours and we've exported them as an SVG. However, if you remember at the very beginning of this video, I talked about using bag data and how we might be able to make contours from that. I used the one that we created early on in this video, however, it didn't work. So instead I downloaded a different bag set. This time I downloaded a bag from Puerto Rico, from San Juan, and we're gonna go ahead and use that. So let's go ahead and drag in that Puerto Rico data. Dragged in, as you can see, it's nowhere near here. So we'll go turn that off, and we will zoom to layer. All right, so this is the Puerto Rico data. It doesn't look good here. However, trust me when I say this is probably a lot better data. They have just made it into a bag file, which is not as accurate. So let's go ahead and make a contour from it. So we'll go once again to raster, extraction, contour. Now we need to select this one right here, which is our Puerto Rico data. We'll go ahead and name it PR, and I'll set this one to 1 again. Okay. And the process is done. Okay. Close. And we'll go ahead and close that. And here is our Puerto Rico data. It looks, personally to me, amazing. It's actually a lot better than the DEM data that's there, as it's more accurate. Maybe not this one, since it's only to like 4 meters or so, but this is now a very recent survey done in 2018 of Puerto Rico. And all the rest of the steps apply. So you can either use bag data or DEM data. But as you can see, the bag data kind of cuts off as we get toward land. And it doesn't cover all of the area either. All right, cool. So those are my tutorials for how to take NOAA data and turn it into contours. Thanks again.